Right. So I also was appointed as one of the head of environmental cluster in my previous faculty of Chemical Engineering in 2018 to 2019. Okay. So before I go any further, so these are the agenda that I'm going to talk about. Okay, I will touch on, so my part will share with you about wastewater treatment in general, and then I will pass the presentation to Mr. Thomas that will talk more specifically on the treatment regulation in wastewater treatment, right? Okay, so I will introduce to you what is wastewater treatment, and then we'll go to basic characteristic of wastewater, and then the source of water pollution by sectors in Malaysia. What are the challenges and the impact of poor wastewater treatment to our environment? And then I will share you the basic wastewater treatment plant, right? And finally, I will also touch about how that wastewater treatment can benefit all of us, okay? Because we think treating that wastewater treatment always burden us because it involves a lot of cost, right? So these past few days, during our MCO, so we've seen some news headlines on how our earth is healing during the MCO, okay? So the picture here was from Feringhi Beach, so it became cleaner during the MCO, right? So the next thing, before I go further, so I would like to, to stress what is the objective of wastewater treatment. As we know that in wastewater, there's specific pollutants that polluted the water. So we want to reduce the concentration of the pollutants into the level at which the effluent discharge will not adversely affect the environmental and also affect our health, right? So in Malaysia, water resources are from rivers, lakes, and groundwater. So mostly comes from the rivers, and groundwater is only like 7% of it. So in Malaysia, we have, based on the data from National Water Services Commission, 95.5% from Malaysia's population are served with piped water. So daily, we are using 16,159 million liters per day. That's a lot, eh? So the water pipeline is being sourced to 97.2% in urban area and 93% to the rural area, right? So that is about the source of our clean water. So talking about the wastewater, generally we can classify the wastewater into two types, which are domestic wastewater, sewage, the one that used in the household, hospitals, schools, okay, shops will be further down, goes to the sewage. These contain 99% water, less than 1% organic, inorganic solid, and also contain bacteria, okay? Then we also have this industrial wastewater, okay? Next. So these are the water usage in Malaysia, how water is being used in Malaysia. Besides then, drinking, we also use the water for hydro plant, aquaculture, agriculture. Okay, there's a lot of agriculture happening in Malaysia, right? So that shows how important the water, clean water to our country, right? So what is the source of water pollution? So basically, I divided into 4 main sources of water pollution. I focus on only in Malaysia, but generally the trend is mostly the same all over the world. So it is due to the population growth. The first one is due to population growth, increase in the commercial area, and urbanization. Okay, so as we know, when the increase in population, especially in cities, okay? So there will be a lot of water to be consumed and end up in having more wastewater produced. Besides than that, by having more population, there's more solid waste produced. And then the solid waste will end up in the landfill. So normally the landfill in Malaysia had a poor wastewater treatment plant, and sometimes, most of the time, the waste is in the landfill is leaching to the underground water and also to the surface water. So this is very, this is happening currently in Malaysia. So it's very alarming. And then the second source is from industrial effluent discharge from the manufacturing industry. Okay, like pume. Pume is one type of, wastewater that have high strength pollution, right? The third source comes from our agricultural activities, which comes from the using of fertilizers, pesticide, fungicide. Okay, this kind of chemicals will end up leach into the underground water as well if not proper wastewater treatment done in the agricultural activities. And finally, the fourth source comes from the land clearing, deforestation. So it's about the rainfall. When you have the deforestation, the rainfall, we cannot contain the water, and then it will be flooding, and this brings the high content of suspended solid, right? Okay, so now I'm going to show you the importance why we need to have a good wastewater treatment. Okay, this is to ensure that we have a continuous supply of clean water, because the water will be recycled, right? Okay, so if we didn't treat properly our wastewater, so there will be water scarcity for us later in the future, right? So to improve, the next one is to improve water quality and water reservoir and ensure sustainability. So for instance, nowadays we've seen that lots of eutrophication. This will affect the quality of the surface water, right? So I will talk more on the eutrophication in my later slide. Okay, the third one on the importance of having good wastewater treatment is to improving resources and energy efficiency. Okay, so we know that wastewater treatment also produces some gases, like carbon dioxide, methane. So when we have a good wastewater treatment, we will reduce all this and we channel those like methane gas to be used to minimize the energy used for wastewater to run the wastewater treatment plant, right? Okay, so now I would like to talk on, this is just the basic characteristic of wastewater, right? So we can divide it into three characteristics. The first one is physical characteristic, second chemical characteristic, and the third is biological. So normally physical, we will measure the turbidity, color, odor, temperature, okay? So the taste, so it's like physically we can see the condition of our wastewater, right? While in chemical characteristic, we will measure on the COD, total dissolved solid, TDS, total organic carbon, ammonia, nickel, nitrogen, and then phosphate, sulfate, the alkalinity, heavy metals, okay? These are under chemical characteristic. And the final one would be biological characteristic, focusing on BOD, and also pathogens in our wastewater, right? So this is about the water pollution source by sectors in Malaysia. So this data I took from Environment Quality Report from DOE in 2017, was released last year. So that in Malaysia, there are 5 sectors, main sectors that pollute the water. So the first one is manufacturing industries. So normally the the characteristic of wastewater produced from this kind of industry is like having heavy metals, high suspended solid, okay? And the second one is agricultural based industry, okay? Like homing, and then the use of pesticide, fertilizer. So normally this kind of wastewater having high COD, BOD, nutrients. When we talk about nutrients, we are actually talking about the contents of nitrogen and phosphate. So by having high nitrogen and phosphate, we know that fertilizers, the pesticide, those kind of chemical used in the agricultural is contain this high nitrogen and also phosphate. This will cause eutrophication. And then the third source comes from the animal farm, especially in piggeries. Okay, it has also the same characteristic: high COD, BOD, ammonia, nitrogen, and also source of pathogen and nutrients. The fourth source is from sewage treatment plants, the one that we produce from the household, the hospital, schools, you know. So currently, the trend is alarming in sewage treatment plant because, for instance, we start to use, people start to use bleaching for cleaning agents. So this one will actually go to our sewage, and we need to treat it very well. So the final one are the source from wet markets. Okay, so here we see some trends of suspended solid, BOD, ammoniacal nitrogen loads that polluted, that produced by the 5 sectors just now that I've mentioned. So here we can see that in all 3 characteristics, we can see that suspended solid BOD, ammonia, nickel, nitrogen producing highest for sewage. Sewage is the having highest BOD, SS, and ammonia, nitrogen measurement, right? So that's why I said this is an alarming indicator to us, because we thought that the household it's not so much thing to chemicals to use to pollute, but we are wrong because we didn't aware chemicals that we use, those bleaching, those antibiotics that we took, right? So this will go to the sewage, right? And then the transportation, the oil and grease, all the heavy metals, and especially during the raining days, this will wash off and goes to the sewage, right? So that's why our sewage is the main contributor on this polluted water. So followed by the piggery, okay, and then next is on the manufacturing. Although in this diagram, we see that the manufacturing industry producing lesser pollutant compared to others, but some of the pollutant, because this is only 3 characteristics, not including the heavy metal, phenol, those other dangerous chemicals, I haven't included in here. So maybe this manufacturing industry is very well known of having high strength of wastewater. Okay, so these are the challenges in wastewater treatment facing by all of us, including the manufacturing industry, especially manufacturing industry. So there are five. There are more actually, but these are the five main challenges in the wastewater treatment. The first one, of course, from rising population, as like I mentioned just now. The second one, climate change. Okay, Malaysia have, you know, musim terkujuh, okay, rainy days. So this one will affect actually your wastewater treatment. Okay, and then wastewater treatment plant will use high energy consumption. The fourth challenges is to comply with the legislation that have been set up by our government. And the fifth one, lack of appropriate technologies, because this one is facing by the whole world. So all these five challenges is actually, giving you high costs. So actually, in the end, these five is actually bringing you to affect your cost, right? So I did some elaboration on all the five challenges. Okay, so for the rising of population, okay, like I mentioned earlier, when especially in urban, in the city, so with increase of people living in the city, increased water consumption and producing more solid waste, and when solid waste without proper appropriate treatment, it will end up to the landfill, and this is more dangerous. It will potentially pollute your groundwater. The groundwater in Malaysia as a water source is only 7%, right? So it is expected that in Asia, it will, in 40 years, it will be double, causing serious eutrophication. So nutrients, the name is nutrient. We thought it's doing good to our water. No, nutrient in wastewater is nitrogen, phosphorus. This will cause eutrophication, right? And it will affect your aquaculture, fisheries, and water quality. Okay, the second challenge just now is climate change. Okay, so like Malaysia, we have heavy rainfall. This rainwater will go to the sewers carrying domestic sewage, and then will enter our sewage even faster, maybe double. So the treatment cannot cope. Okay, maybe it will cause some overload. So that's why when there's climate changes, this is another challenge for country like us lah. Especially when we have flood. Okay, so this one with the untreated sewage, it will go to our rivers, lakes, and coastal areas, right? Okay, so high energy consumption. So wastewater treatment plant in the whole world use 2 to 4% of total electricity. So this is a huge. I know that some of you from industrial background and some of you are students. Wastewater treatment plant in a process plant is not. It's only a small part of the process plant, but this part is using 2%, 4% of electricity, okay, which is quite a lot. So this will make the high operating cost, and then we need to know. So that's why currently there's a lot of research being done on how we can reduce this kind of energy consumption, right? So for instance, maybe we're using a different kind of absorption, and then sometimes we can produce energy like methane from the wastewater that will be recycled back to the electricity will be produced from the methane and will be recycled back for the use of the plant. So we have now currently in Malaysia, right? And the fourth challenge is complying with legislation. So there's a lot of rules and regulation that especially the manufacturing industry need to follow. And then the waste sludge that are being produced normally mostly classified as schedule waste. And then, so we need to pay to, we need to pay to get rid of the, dispose the sludge. Okay, so these are common problems facing in most plants. So, for instance, for water treatment, they're using alum for coagulation, flocculation, and end up having this alum sludge after being used to treat water. So, I've involved in recycling back this kind of alum to be used is either to treat the water back or to use it in other applications, right? And then some of the sludge also are sent for incineration, which is consume a lot of energy and also a lot of cost. Okay. And the final challenges are lack of appropriate technologies. Okay, because some of our infrastructure in our our wastewater treatment plant is outdated, right? Cannot cope. The the effluent is double, but the technologies or the plant remain the same. Okay, and we also lacking of certified people. Okay, the competent person in operating the wastewater treatment, right? So this is not only faced by us in Malaysia, but it's all over the world, like India, right? Okay, these are the impact of poor wastewater treatment, like I've mentioned just now. So we are the main users, okay, human, animals, okay, and also for the agricultural, right? So all these, it will end up, okay, like human and animals will end up in sewage and go for the wastewater treatment. The agricultural also normally, okay, it's very rare to see. I don't know. I don't have so much experience on observing wastewater treatment plant in the agricultural farm. But from what I've observed, the wastewater treatment, they didn't have the wastewater treatment, or if they have, it's very poor. So they end up all those fertilizers, pesticides that used will leach to the underground water. Okay, so this will cause, this will, the water, the quality of the water will affect our health. So we have metabolic disorder, hormonal imbalance, okay? So these are the consequences. So this diagram on my right also tell about the same thing. So nowadays we have, medicals, antibiotics, okay? The landfill, leach, the landfill leaching, the water leaching into the groundwater and surface water, the agricultural, from the animal farms, okay? So these are all causing the water polluted, right? Okay. So if you're not doing a proper wastewater treatment, we will see that all these will go to our water resource, okay? So surface water, groundwater, and we are the one who will be using the water, right? Okay, now the next one is the impact of wastewater is eutrophication. I've been mentioning about eutrophication earlier. So eutrophication is actually caused by the nutrients in the wastewater. Nutrient, when we talk about nutrient, is nitrogen, okay, phosphorus. So this nitrogen, phosphorus is like giving nutrients for the plant to grow. So it will, that's why we will have algal growth when you have more nitrogen and phosphorus. So when the algal growth, and it will becoming algal bloom. So because the alga will use carbon dioxide and producing oxygen, And then when there's algal bloom, it will cover the water, and this is what we call eutrophication, less oxygen, and that's where your quality of your aquatic life, okay, you will see dead fish, okay. So this is not good, all right. Okay, so the next one, okay. So I have experience in dealing on the eutrophication on one of the process plant in Gebeng, where they have a problem of high pH in their facultative pond. So when we see physically, we see the facultative pond is already full of algae. So this indicates to us there's a eutrophication exists in the wastewater. So the source of the nutrient, phosphorus, actually comes from they're using potassium hydrogen phosphate, to prevent or retard the scale formation and corrosion in their water distribution system. This is a normal method used in process plant, because we want to recycle the water, so they inject this potassium hydrogen phosphate. But this phosphorus from the phosphate will actually causing the algal growth in their wastewater, in the facultative pond. So we have solved that, and this besides than that, the pH will become more alkaline. Okay, so cannot discharge the water, right? So these are another effect of poor wastewater treatment. If you can see, there's oil spillage. Okay, this is often happen in, sometimes happen, not often, sometimes might happen in oil and gas industry, right? Okay, so this is the basic wastewater treatment plant. This is just a basic. Nowadays there's a lot of more recent technology used to treat the wastewater. So basically, we divided it into three major parts. Actually, some of them have pre-treatment before the primary treatment. So it depends lah. So basically, we have these three lah: primary, secondary. So and then the third one is to how you treat your sludge. Okay, it's either before you dispose it in landfill, or incineration, or you use it, for other application. So like I said just now, maybe some plant they have pre-treatment. It's to remove large object so that it will not damage the equipment. Okay, and then only they go to the primary treatment. Okay, to reduce the fine particles, the suspended solid, and then all grease. Okay, and then if you see in the primary treatment, if you see the settling tank, so the solid or will settle down, and this sludge will go to the sludge digester. So the treated, okay, the supernatant will go to the aeration tank. So here where we start our secondary wastewater treatment. So this normally for secondary, normally to degrade the soft content of the sewage with a biological degradation system. Okay, we use activated sludge. Okay, so we have microbe to degrade some soft components in water. Okay, that cannot be treated during the primary treatment. Okay, so the final step in the secondary stage is to separate the biological media, the microbe that we used just now, from the cleared water. Okay, so if you can see here, after the aeration, so all those micro and all those treated, all the sludge will go under and will be sent to the sludge. And the clean or treated water will go to the chlorine or disinfection tank. Okay, so there's a few methods to do some the disinfection tank besides the chlorine. Sometimes they use also UV. Okay, It depends, and some plant they have also the tertiary treatment. Okay, for like especially to further treat the nitrogen or phosphorus. Okay, in the wastewater. Okay, and then the sludge digester is where you treat your sludge. Okay, so this sludge treatment will involve some thickening, stabilization, conditioning, dewatering, and reduction. Okay, so there's a lot of studies now, on recycling back the reuse or recycling the sludge, to optimize the cost lah. Okay, so my final slide is on how wastewater can benefit us, because earlier it seems like wastewater treatment will cost more, will have more higher costs. Okay, so but in a positive way, we can see that of course it increase sustainability because you are reusing back the water. So it's not only preserving the water source. This treated wastewater can be used in other industry. Let's say you treated the wastewater from the manufacturing industry, we can use it in the agricultural industry. Okay, so when we treat our wastewater, less eutrophication, marine ecosystem can be protected. Okay, less waste is reduced. And then energy self-sufficiency. So currently, like sludge produced from the wastewater was used as a source of methane for energy generation. This is applied, for example, applied in some of palm oil mill effluent water treatment, where they use this foamy as as a source of methane. Okay, so this methane will be filtered and then will be source of energy to produce electricity. So we have this kind of plant somewhere in the Pahang, near the oil palm plantation. Okay, the next one is enhancing the resilience. Okay, so better health, good water quality. Okay, and then you can reduce flood. Okay, because by having proper wastewater treatment, okay, the drainage system all will be very well planned. Okay, and then improve asset life, rural area with seasonal increase in population, and then it will reduce water scarcity. Okay, and then the next one, we develop new market product. Okay, selling new technologies, and this will create more job opportunities, and then such as computer person, wastewater treatment plant operators. And finally, it will improving innovation. Okay, because we have a lot of problem on wastewater treatment, type of water pollutant. So this new knowledge is being used, new knowledge is being invented. Okay, to treat the wastewater. Okay, for instance, nowadays they have advanced oxidation, membrane technology, electrocoagulant, ultrafiltration, and currently, they suspect those, during the MCO, they suspect those COVID virus also present in the wastewater. So that's a new knowledge on how can we treat this COVID-19 virus in wastewater treatment plant, right? So I think that's all from me now. Thank you for listening. I would like to pass my next to my co-speaker, Mr. Thomas. Thank you.
All right. Thank you, Dr. June. Okay, next session will be our second speaker, Mr. Thomas.
Yeah, thanks, Ms. Shavika. So now I share my slide first. Okay. Yeah, thank you to Dr. June for the sharing of the overview of the wastewater treatment here. Very good morning, everyone. Welcome to our webinar today. I will be discuss more on the environment protection in the industrial practice here. My name is Thomas Woon. I just finished my PhD research in this palm oil meal effluent treatment process by activated processor in UMP. So currently I'm a general manager in technical and innovation department in ICAM Solutions in Pahang. So I also, ICAM is one water treatment company in Puchong. We're doing the supply and consultant for the industry, especially in water treatment part. So I'm the competent person in wastewater industry for biological process. We call it CPSO, BP, and also physical chemical process. So CPSO, PCP. Besides that, I also a certified trainer and assessor to provide the technical training and support to our internal staff and also our customer, especially during this commissioning or operation side. Last year, Kim River was polluted by the illegal chemical waste dumping, which affecting about 6,000 people and hospitalizing about 2,000 plus. Most of the victims were school students, and about 110 schools located near the river were subsequently closed. This incident gives us awareness of the environmental protection, especially the commitment need to be given by the industry. So for today's webinar, I will share with you all the environment protection in the industrial practice. In fact, all the waste, regardless liquid or solid waste that produced from the manufacturing activities need to be controlled and monitored before discharged to the water bodies for the following reason. Yeah? So the first reason that we need to have wastewater treatment to reduce the impact of impurities on the environment and public health. And second, ensuring this conformity with legislation, regulation, standard, and codes. So I'm more focused on the regulation what in our country for the wastewater part. In implementing of this environmental law and regulation, the Environmental Quality Act 1974, sometimes we call it EQA, has been introduced and are strictly enforced by the Department of Environment. Sometimes we call it DOE. So I think most of us very familiar with this DOE, Department of Environment. So in industry, usually there are two regulations that always been referred to control and monitor the liquid waste and solid waste in manufacturing activities. So the first one would be the Environmental Quality Industrial Effluent 2009. We call it IER. IER 2009 and Environmental Quality Schedule Waste 2005. So these two regulations is always we use in industry part. So in industry practice, these two regulations have been widely used. Yeah? So in this IER 2009, I've listed down some regulation that related to the industry practice for today. So this is the summary that I'm listed out. So for some very important regulation here. So for the first one, in the regulation 5, talking about design and construction of the industrial effluent treatment system, or sometimes we use IETS. So IETS is a word we always use in the wastewater. Yeah. So for the regulation 5, factory need to appoint a professional engineer to design and construct the IETS based on the specification in the guidance document on the design and operation in IETS. This document is issued by DOE. So all the design we must follow the guideline in this document here. So after that, in regulation 6, all the factory need to operate the IETS to comply with this design specification. So when you build it, make sure all these designs comply. Yeah? Then after that, regulation 7, talking about the monitoring of final discharge. So the factory required to monitor the discharge of industrial effluent, ensure that the discharge quality is compliant to the DOE regulatory standard, discharge standard, either standard A or standard B. It based on the area that the premise located. Yeah. So and regulation 8, so the factory need to operate and maintain the IETS to ensure that all the components of the IETS are worked in a good working condition. All components means that every unit operation that built in the IETS, they need to make sure all the unit operation is work in a good condition. Yeah. Then regulation 9, you need to conduct a performance monitoring for all the component of unit operation in IETS according to the guidance document on the performance monitoring. This document also issued by the DOE. So it means that we have two guidance documents. Yeah? First is design. After that, we need to conduct a performance monitoring based on that document. So regulation number 10. So IETS need to supervise by the competent person, yeah, who has been certified by DOE and on duty and any time when the ITS is operation. So this is stated in the regulation. So as long as your factory is operation, make sure you have a competent person is on duty because you need to supervise the overall ITS operation. Yeah. Then regulation 11, 12, and 13 talking about the acceptable condition of discharge. So the discharge parameter that we have a 3 regulation. 11 talking about all the parameters except COD. Yeah? So in the COD, they were mentioned in regulation 12 for the IE industrial effluent. And the regulation 13 talking about the mixed effluent for the COD standard. Then the final regulation 28 will be a personal training. Means that the factory need to provide training to the IETS personnel, especially EPMC. So EPMC here, we're talking about the Environment Performance Monitoring Committee, which also regulation stated in the regulation in this competent person course. So this is the regulation about this IER 2009. But in the regulation of schedule waste 2005, all the waste that fall into the schedule waste category must comply all the regulation that's stated in this regulation here. So I also highlight for some quite related to our topic today. So the first one is the regulation number 8. So it's responsibility of waste generator. So factory or waste generator need to ensure that all the procedures of schedule waste management in accordance with the DOE guideline. So when you produce a wastewater and your wastewater produce a sludge, when the sludge fall into a schedule waste, make sure you follow the procedure. Yeah? And the regulation 9, you're talking about storage of schedule waste. So in this regulation, the factory or the waste generator must follow the storage of schedule waste, keep the generated schedule waste not more than 180 days or not more than 20 metric tons. And the regulation 10, talking about labeling of schedule waste. So the factory need to label all the schedule waste in accordance with the specification in schedule waste regulation 2005. And in regulation 11, the waste generator need to keep the inventory record up to that inventory record for a period up to 3 years. Yeah? 3 years from the date of the schedule waste was generated. So the record, whatever record you reduce, you need to make sure it proper, record it and keep for 3 years. When the DOE officer come inspect, they ask document, so the factory need to show this record, evidence that they have a well record and follow the regulation, the guideline. And regulation 12, they are talking about the information to be provided by the waste generator, contractor, and occupier of prescribed premises. So all the information of the schedule waste need to record from the waste generator, means that the factory, when you produce the schedule waste, you record it. After that, another part is the licensed contractor who delivered the schedule waste out from the waste generator premises. So it means that when you want to discharge, you know, take out all this schedule waste, make sure you hire this licensed contractor who is registered with DOE, then send to the schedule waste receiver for the treatment or recovery. So here maybe mostly they will send to the quality alarm. So in this case, this is about some field regulation that related to our industry. So generally, there are few proceedings need to be carried out in the industrial effluent management. This is a 4 preceding that, we always need to refer. The first one is the ITS effluent characteristic study. We call it IECS. We need to study the characteristic of the influent. Then second is the industrial effluent treatment system design, ITS design. Third one is the industrial effluent treatment system operation and optimization. Yeah, so ITS operation. Then the final one that everybody were concerned about the cost. So later I will share some cost effective in the industrial effluent management. Yeah. Firstly, the characteristic of the industrial effluent need to be determined prior of ITS design that's stated in the IER 2009. Yeah. So they are total have 31 parameters that stated in the FIT regulation in the IER 2009 that always been used for IECS, Industrial Effluent Characteristics Study. So this is about this summary for 30 parameters. So this all testing only can done by the accreditation lab, which has been accredited based on ISO 17205 under the scheme of the SAMM, Scheme Akreditasi Malaysia. So for those lab doesn't have this accredited certificate, so we cannot did all this testing because not recognized by the DOE. So make sure whatever the ICS you want to do it, make sure the lab you are sending to, the sample sending to, make sure they are certified by this ISO 17205. Yeah? So then the ITS will be designed based on the non-compliance parameter that reported in the IECS report. So when do the testing, they are complete this IECS report. So the consultant will select for those non-compliance parameter. Then they will use that non-compliance parameter to be designed to comply the parameter that's stated in the DOE regulatory standard according to the guidance document on design and operation of ITS. As I mentioned, this document is issued by DOE. So all this design, we need to refer to that guidelines. I think almost all the when they go for the competent person course, they will provide for you these two documents. This is one example of the ITS design calculation here. So you can see all the unit operation like aeration tank, air blower, primary sludge, biological sludge, primary salination. All the unit operation have been calculated based on the factory specification, the flow they come out. Then they calculate one by one. So this one by one, they will calculate for the whole entire ITS before we go for the engineering drawing. This is in drawing. Once the calculation is complete, the drawings will be prepared accordingly for this example. One example that the engineer will prepare this drawing. Then this drawing will be used to construct the ITS. So this is our flow of this design and build. So after completion, the build and construction of ITS need to operate based on the system design specification and regulatory compliance. So just now, the wastewater have been designed based on specification, then have been built. After build, need to operate it. So we need to operate and optimization in this part. So in the ITS operation, I select 4 part is quite related to our this part. So in ITS operation, the optimization of the entire ITS is crucial to ensure the effectiveness of ITS in treating the industrial effluent for the regulatory compliance. Therefore, performance monitoring of ITS need to implement by competent person. And this competent person will be assisted by the ITS personnel training, especially Environmental Performance Monitoring Committee, because EPMC, just as I mentioned, EPMC. So this committee need to form in the factory. So this committee will responsible to take care of the wastewater treatment plant. So by leading by the competent person. But then the EPMC need to go through a training by the competent person to make sure they have competent to do a testing, to do some daily operation in ITS. Prior of optimization of ITS, understanding the entire operation of ITS is needed to ensure the ITS is well operated and controlled within the design specification. So when we're doing the optimization, make sure the whole unit operation of ITS we understand. What is the system they are inside your ITS, because the various of technology or system that being used is subject to your flow of your process here. So in general, the ITS process can be divided by two main categories, namely physical chemical process, we call it PCP, PCP, and the biological process called PP. So this is two main category. So for those factory, you must make sure understand what is your process in your ITS, either a PCP or PP. So in physical chemical process, PCP, mainly to remove the suspended solid through the coagulation and flocculation process by using the coagulant and flocculant. For some, they have a metal issue. So in the metal remover, normally caustic or lime will be used to precipitate the metal out from the influent. So this is in practice in the industry for PCP side. For the BP side, the dissolved organic matter need to remove it in this BP process, namely BOD and COD. Will be removed biologically by active sludge, which consists of bacteria and microorganisms in the active sludge. So this is a two-part, is a measure for the function of BP, PCP and BP. So from the design process flow, we can understand the whole operation of ITS and all the unit operation involved. This is very important because every unit of operation has their own function in the entire ITS and eventually produce the final discharge that comply with the regulatory discharge standard. This is most important. This is more important. If one of the unit operations malfunction or not perform well, the whole ITS will be affected. So we need to ensure that all the unit operation in the ITS is work well consistently. This is very important. So all the unit operation, you must understand what the function of it, how to operate it, what is the limit of your design. Make sure don't over the limit. Once over the limit, they have a difficulty to get the high quality of discharge. So the typical of the flow process. The design is up to the factory process here. So in order to ensure that all the unit operations are in good operation condition according to the design specification, performance monitoring program need to implement it to the entire ITS. So this is one of the ITS example for the food processing factory. So I use one example. This is a food process factory. Normally they will have a PCP and BP, physical chemical process and biological process. So from the IECS flow, there are 7 unit operations have been identified as shown in this presentation slide. So the first one, EQ tank, chemical dosing system, DAF, dissolved air flotation, DAF, aeration tank, then secondary clarifier, final discharge, and sludge dewatering. So performance monitoring parameters for each unit operation is designed follow the guidance document on the performance monitoring of ITS, which issued by the DOE. So once we identify this unit operation, then we will refer to this document. Then we will determine what parameter we need to put it in our performance monitoring. This is very important because if one of the not 11 parameter you put in, maybe you're quite difficult to control it. This is the performance monitoring part here. So in order to implement the performance monitoring program, the performance monitoring laboratory need to be set up by completing all the equipment in the ITS. So this is an example of the lab. This is one of our customer. We help them to set up the lab, and also this is equipment that been widely used in the performance monitoring lab for performance monitoring parameter testing. So the lab, the equipment, it depends on what parameters you want to do it. It depends because it's not all the parameters you need to do it, but still need to refer back to the guidance document. So this is the list of the apparatus and equipment. So this is example of performance monitoring log sheet for aeration tank, for example. Because the log sheet just now is 7 unit operation. Every unit operation we must have one performance monitoring log sheet for every unit operation. This is an example of the aeration tank. Yeah. So in aeration tank, they have two kinds of data. One is the primary data, filled in the white color column, can be obtained from the online monitoring equipment like pH meter, ORP meter, and also the laboratory analysis result. That's, for example, is a SV30 or MLSS. This all can be obtained from the performance monitoring laboratory. Once you get the primary data, then the secondary data will be calculated from the primary data. This is in the green column. This is an Excel log sheet I'm create for our customer. So from here, when they fill all these primary data, then I will key the formula for in the green column. So it will auto calculated. So easier for the operator to monitor the data here. So in here, they also have two testing frequency, daily and weekly. So it depends of the parameters here. So still we refer to the guiding document. So what parameters is fall into the daily testing, we just follow daily, and which parameter is the weekly. So this is parameter we need to determine the parameters, then the test frequency, the primary data and second data. This is we have another part is called data management. This for performance monitoring data management. Once the performance monitoring log sheet is completed with all these control limit values, then the performance monitoring control chart need to be done by converting all the performance monitoring data into the graph plotting. This is example of the control chart. So complete with this title. This is COD for y-axis and the date. So make sure the date is is correct. What your data is collect there. So from here, we know our performance, our COD chart all the time comply with this standard B. This is what we call performance control chart. So easier, because if some people they cannot read the data is quite difficult to let us justify is it our performance is within the control, is within the charts, quite difficult. That's why we convert it to the graph, and easier for us. Especially for top management, they're not going to read data by one by one, but then they will just go through the graph. So this is the purpose that we need to show the graph. This is called performance monitoring control chart. It's although we also mentioned in this DOE requirement. Yeah. So according to the EQA 1974, the Environmental Quality Act 1974, factory need to select a person who is in charge of ITS or supervise the operation of ITS to be certified by DOE to become competent person. So before the certification process, he or she need to attend the training course which conducted by the EMAS, Environment Institute of Malaysia. Then completing all the course assignment and passing the comprehensive exam. Once he pass the exam, he or she will be awarded for 1 year pre-competent person certificate. So within 1 year, he obtained this license, he can operate the wastewater, but then within 1 year, he need to prepare the field training report, we call FTR, submission, then attending the professional interview conducted by EMAS. This is the process of certificate process. So once he or he passed the true certificate process and certified as a competent person, a certificate environment professional in ITS operation, we call it CPSO. Yeah? CPSO, he or she will be awarded CPSO certificate as shown in this present slide. So if you are in BP, so you are showing CPSO in BP. You are PCP, CPSO in PCP. So they have two. And they have under extra, they have few competent person as well, as KD waste, like as scrubber. So they feel pump oil mill, pomade. So all the competent person before he completed get certified, need to go through the certificate process, take for exam, all these things. So this is the process of a certification here. So in order to implement the performance monitoring program, the competence can be assisted by the Environmental Performance Monitoring Committee, EPMC, mainly consists of ITS operator, performance monitoring lab assistant. So hands-on training need to be conducted by the competent person to all the ITS personnel to ensure that they are competent in ITS operation and performance monitoring program, yeah, especially in data collecting and laboratory testing. That's very, very important. If they are correct the wrong data or inaccurate data, then you have the difficulty to have a good control in your operation. And also same to the laboratory testing. So because in the performance lab testing, they have arranged a lot of testing procedure they need to follow. So make sure they're competent, they are doing the right job. As shown in this business slide, all these ITS operator is trained by competent person to conducting this performance testing in a laboratory to ensure that they are the testing procedures correctly and obtain the accurate and representative result that need to be filled into the performance monitoring log sheet. So make sure the competent person, make sure all the operator, they do the right procedure. This is very important. So competent person have responsibility, make sure all the ITS personnel do their job correctly. Yeah? So in fact, even though the ITS is well controlled, well operated, most of the factory is still concerned about cost reduction, especially in ITS operation. Yeah? So because in the ITS never bring the profit to the company, so all the time the management always looking for a cost reduction in the ITS. We call it wastewater treatment plant. Thus, ITS cost management can be done for the entire ITS operation. So let's take a food processing factory as an example. Yeah. So as mentioned just now, the food processing factory normally they consist PCP and BP. So we can separate the total cost into these three portions, namely PCP treatment cost, total treatment cost, or BP active sludge optimization, and also the sludge, which produced by PC in the PCP or BP. In the sludge produced in the PCP is called primary sludge. If sludge produced in the biological process, normally we categorize as a secondary sludge. Yeah? So in the PCP, the cost-effective management can be done by analyze and evaluate the total treatment cost. In the BP, optimization of the active sludge process can bring the benefit of the intangible cost saving. They're not direct cost, but then we optimize it, you can see intangible cost here. And for sludge disposal cost is very depends on the types, what type of the sludge you produce, and the volume of the sludge production. So mainly the cost is from three parts in the ITS if you have PCP, BP, and a sludge part. Yeah? So normally the main treatment cost of entire ITS in the PCP, PCP, where the chemical will be used such as coagulant, flocculant, pH adjuster, and other chemicals in the primary treatment. In order to reduce the chemical treatment cost, manufacturers is always looking for the cheaper unit price of chemicals, but not really study the unit treatment cost. Yeah? So what difference between unit price of chemicals and unit treatment cost? So as shown in this table, let's say for example, I have two types of coagulants. One is the PAC, polyaluminum chloride, and another type is organic coagulant. Yeah? So in a PAC, the price about 250 per kg per kilo, and those is 150 ppm. Yeah? So giving the unit treatment cost about 38 cents per meter cube. The unit treatment cost per meter cube. But then when we look at the organic coagulant, even the unit price is high, about 6 ringgit per kilo, but those at a 50 ppm only. And the unit treatment cost about 30 cents. So we can see it, even the unit price is higher, but treatment cost is less. So this is a very obvious, we can get a good cost saving. So it's shown that even the organic coagulant at higher price, but low dose and low dosage, so eventually it will low down the total treatment cost. This is how we do the costing for deduction here. Moreover, when using PSC, the pH of influent might be dropped. So you need to adjust the pH. I put in some the caustic soda. Normally in industry, they use caustic soda to increase the pH. Indirectly, it will incur another extra cost for P adjuster. So about 30 ppm, let's say 2 ringgit, so another 6 cents. Another 6 cents will increase inside your entire treatment cost here. But if you use the organic coagulant, they will not affect the pH. So the pH adjuster is not necessary. You save another cost. But the flocculant will be same, 6 ppm. So it's clearly show that it's about, from calculation, of 26% of cost difference by using organic coagulant with higher unit price compared to aluminium with lower unit price. This is how we do it, this cost saving. So a lot of factories, they not realize that they want to buy the PSC from A company 250 and company B PSC 240. There's in the book they can say the save 10 cents, but in fact it's not, because maybe the dosage is almost the same. So this is how we help the customer to do the cost saving in the wastewater part. Yeah. Nevertheless, optimization of PCP need to be conducted by daily basis. So even we know how to control it, the dosage cost, but then we need to do the jar test every day. So to ensure that the chemical is dosed at the right dosage. Then the jar test also one of the testing that we need to do in our performance monitoring program. So this is for the cost saving part. This is all for PCP. Yeah? So in the BP biological process, the effective cost management can be done by optimize the active sludge process. So mainly in the BP process, the active sludge is mainly be used it. So there are many methods you can control and enhance the performance monitoring in active sludge process. But today, I just will share with you 3 methods. So the first one is sludge age. Sludge age, or call it MCRT. Some people call MCRT, mean cell retention time, or some people call HRT, sludge retention time. Yeah. And second is food to FM ratio. FM ratio. This is another method. And third one is a dry cell bacteria. So this is three of these method. And for BP part, for the biological process. For the first method, by increasing the sludge age. So when you increase the sludge age, the waste active sludge, we call WAS, wasting active sludge volume will be reduced. Then will be reduced, then your sludge volume will be less. Then it directly will reduce the secondary sludge volume. Then when you dispose, you also can solve your sludge disposal cost. This is the one method. And the second method, to increase the FM ratio. FM ratio, if you increase the FM ratio, means that the aeration tank able to receive the higher BOD into the aeration tank. When these are influenced with high BOD, means that you are in front of your PCP, you can reduce the chemicals. You can reduce the chemical, then the BOD will increase, then by allow you to operate at high BOD. Yeah? So this is directly can save your cost in the PCP. This is another method. Third method is using external dry cell bacteria to enhance the performance of biodegradation process in aeration tank, especially for those factories facing a difficulty in discharge standard compliance. But they do not have budget to do the upgrading the existing IETS. Some factory they have concern about the budget, and also some factory they have a restriction of the area, cannot do the upgrading. That's why, but they need to comply it. So they think about how to get compliant. Then this is another way we can help to put some dry cell bacteria, add on the hyperactive bacteria together with the indigenous bacteria, then to increase the biodegradation process in the aeration tank. Yeah? This is the 3 method I just shared by today. And the last one, finally, the effective cost management of the sludge can be done by converting the inorganic coagulant in PCP. Just how I mentioned, you use PSC, yeah? Polyaluminum chloride is an inorganic coagulant. Some they use the alum, or called aluminum sulfate, or ferric chloride, or ferric sulfate. So we can convert all these inorganic coagulant into the organic coagulant to produce the non-scheduled waste. For information, if any waste that contain aluminium, automatically it will fall into the scheduled waste with the code SW204. When this last categorized as scheduled waste, all the waste you cannot simply landfill. You need to follow the scheduled waste procedure. You need to do a storage, labeling, the disposal, follow the scheduled waste. And also when you discharge, you dispose the sludge, you cannot simply to landfill, you need to send for the quality alarm. You pay more cost. So as a guideline, one of my customers, they charge this 1 ton of the SW204, 2,750, exclude toll and this transport. So this is a highly cost for the scheduled waste. That's why we try to convert it, produce non-scheduled waste instead of scheduled waste. This can be done especially for food and beverage industry. For those food and beverage industry, we always recommend you try not to produce scheduled waste, produce a non-scheduled waste. Easier for disposal and also can save a lot of cost. Furthermore, the sludge disposal cost can be reduced by reducing the sludge volume production through this sludge dewatering process. So you can enhance the optimization, the dewatering system to remove the moisture content in the sludge and eventually reduce the total volume of sludge they're going to dispose. When your volume will reduce it, definitely your disposal cost will be less. So this is how we do it cost saving for other factory. Yeah? So that's all for my sharing today. Thank you everyone for your time and participation. I give it to the Ms. Shakita. Thank you.
All right, thank you, Thomas. Okay, we start with the, okay, actually there's one question. Wait, I share my screen. Okay, there's a Q&A question. There's one question from, one question from F. Marcin. Mr. Thomas, performance monitoring, is it only COD will be doing by chart or all parameters will be do the same chart?
Different chart. You have every performance monitoring, they have their own unit operation, and also you need to have these parameters. So that everyone have the single chart easier. Because if you're lumped together, sometimes it's quite difficult to see the graph. So my practice, I do it single by single.
Okay, thank you. Does it answer your question, Mr. F. Marcin? Is it Mr.? Okay, next, Dr. Adi also comment a bit. Need to add the cost for disposal SW204 to quality alarm or landfill.
Normally, if we have SW2,
okay, it's okay. You can continue.
Okay, normally if your scheduled waste fall into SW204, definitely you send for quality alarm already. So as I have my customer, last time he also produced this, they use a PSC as a coagulant. Then after that, the sludge categorized in SW204. So when 204, the DOE not allow you to for landfill. They need to apply, then they send for quality alarm. 1 ton about 2,750, 2,750 from Kuantan, yeah. Exclude the transport and this toll fee. The quality alarm will take a licensed contractor to carry for you. I need to pay the cost. Cannot for landfill. Cannot for landfill.
All right. Is there any other question from the participants? Actually, you can also.
Yeah, I would like to on the quality alarm as well. So just for your information, so we also, UMP also have a collaboration with Senbiro, now known as Senbiro. So they gave us, I think last year, because they have also several problems on, with their solid waste, lambatkan waste orang. So there's some collaboration on what to do with the waste. So there's a few research collaboration between UMP, which is in chemical engineering department, okay, with Senbiro. So there's a few projects, and currently we also, making those projects to be given to our undergraduate plant design project. So actually, that's what UMP try to engage the industry collaboration with our students. Yeah.
Okay, thank you, Dr. Jun. Okay, this one from Rocky Tan. Mr. Thomas, what are the type of wastewater that ICAM treats and where do they come from?
Okay. Actually, I can never treat any wastewater. ICAM is a company that will produce this consultation to the factory. We provide the design, the solution for the industry. We not treat the waste. We will help the customer how to manage their waste. If they say your waste fall under schedule waste, then you need to follow the schedule waste procedure. If you are, we try to help the customer to treat the wastewater in the minimum cost. This is our job. We are not this something like quality alarm. Quality alarm, yes, they treat the waste, but I can know. I can do the consultation.
All right, thank you. Okay, there's one more from Dr. Hadi. This was nice question. Can you offer some suggestion if the management does not interested financially in WWTP?
Suggestion not interested in financial means that they're willing. They're not going to not interested financial means that they are willing to invest or not going to invest.
I think they're willing.
Normal is a normal thing.
I think it's not going to. I think not going to invest lah. I mean, yes, minimum investment. So the first thing, again, we need to go back to a regulation first. Because the regulation, if you cannot fulfill this requirement of regulation, you cannot talk about the cost saving. The first one must come the regulation first. Because once you comply it, yes, you can do some cost saving, you do minimize your investment. So I think this is quite a subjective question because the compliance is first. Compliance is first. Because DOE have right to seal your factory if you disobey the regulation, yeah, never follow the regulation, they have authority. Firstly, they will come to give a fine, send to your court, then finally they will seal a factory. So they are regardless you like it or not, you still need to comply the regulation. Put some invest to minimize it. Then when you put it, our consultant team will come in, help you how to minimize the cost. Definitely you need to come out with some money.
Okay, I will add up on that as well. So if let's say reluctant, yeah, because of cost, so we have several options like what UMP has done, what I have done with some of small industry. I'm talking about small industry, SMI. So let's say we collaborate like an agricultural, very small rock melon industry, but they don't have proper wastewater treatment. What we can suggest to them, I did suggest to them, we can collaborate in research and try to apply some research grant. So there's a lot of research grant offered from MUSTI, and then even those problem statements from the industry can be a topic for research grant from the university to apply. So it's a collaboration actually. It might not help 100% to cover the cost, but at least it will reduce some costs because it's the collaboration between the industry and also that's what I can at least do lah. Okay.
All right, okay, thanks for the explanation. At least some of them will know that can collaborate with universities to apply for grant. Okay, next from Cheryl Ching. What will be the basic wastewater treatment for durian product processing factory? Minimal water discharge compare other food industry.
Okay. The first question, what is the basic water treatment for durian factory process? Normally, if they say you are a factory, you automatically you will fall into IER 2009, Industrial Effluent Regulation. So normally when you have this kind of thing, you need to run a so-called the IECS 31 parameters to make sure your what is the non-compliance parameter in your wastewater. Then from there you design. So there's no minimum water discharge. It's based on your process. So you can discharge based on your process. Then we'll calculate what is the flow rate you'll discharge. Then from there we will design accordingly. This is for all under is IER 2009. Yes.
All right, thank you. Next from Muhammad Zainuddin Zakaria. Hi, Dr. Jun. How to reduce 4-parameter ammoniacal nitrogen?
Okay. There's a lot of, treatment can be done. One of the basic one is by using adsorbent. So there's a lot of type of adsorbent. The expensive one is activated carbon. So if there's a lot of research currently that try to replace the activated carbon, so which less cost. So the most simple method is by using adsorbent to absorb those, the effect, the ammoniacal nitrogen. That is one way. There would be a lot other lah, but it will need some, lengthy time to explain. You can also like email me for, for further explanation. Like,
so roughly the cost would be, how much the cost for the adsorbent? Maybe they can prepare for the cost to buy the adsorbent to reduce the ammoniacal nitrogen?
It depends. Like I said just now, the strength of wastewater, and then if you're using activated carbon, it's one of the expensive kind of adsorbent. A few years back, we have tried to, to solve this ammoniacal nitrogen in one of the plant in Gebang. So we, we produce our own adsorbent. It's from the cockle shell and then from some other waste source. Normally from the waste source, that is the most cheapest lah. But by having some of the drawbacks of having that adsorbent, you need then to, you will produce a sludge then. So you solve another, but you produce another waste. So that's the thing lah. But it cannot be one treatment, it will be a series of like after absorption, maybe some, other separation units, and then the sludge treatment. So then only it will help to, solve entirely the problem.
Okay, thank you. Okay, next from Mr. Saudin Sulong. If the factory can eliminate the heavy metals being produced before with the new invention or change the chemicals such as raw materials or any other process, is it we can change the title of submission to DOE as a landfill only? Then how long it take for the process with DOE?
Okay, for our experience, this is according to their standard. They maybe say 4 to 6 weeks, but also we have a few case different type of period. Some 4 working days we get it approval, some cannot. So it depends of the documentation to submit and follow up. So I cannot give actual the date or the duration that the DOE approve it. It's still subject to the DOE officer. And also the document is it complete, not complete, and need to click follow up. So I here sorry to say that I cannot give the actual duration because it's case by case. As our practice, I do help the industry. Some faster, some get some longer time. So still depends of the officer. How do you collaborate with your officer, and also make sure the document everything is complete. Then you can faster your process. This is how I can advise. But anyhow, you still need to talk with the DOE officer. Keep close monitor, follow up. That's my advice.
Okay. All right. Okay, from F. Marcin, have the speakers encountered whereby BOD is higher than COD data? Any insights on this?
I have read article, yes, the BOD can be higher than COD, but for my industrial practice so far, I didn't see the BOD higher than COD lah. Our practice, the COD always at the higher side. But they have an article. I read the article before. The BOD sometimes it can be higher. So can you want to share by Dr. Jun? Any comment about this statement?
from what I've known, normally the COD ratio to BOD is normally higher. So the
Yes.
maximum would be, 4, and that is considered very high strength water. I haven't, since I have a limited experience also with the wastewater treatment experience, consultation. I haven't seen this, so maybe what do you, F. Marcin, what may I know what kind of wastewater is that? Having BOD higher than COD?
Maybe you can type in the chat box, F. Marcin.
Yeah, maybe I read, yes, they have a special case BOD higher than COD. They have case, but then so far in the industry, I never see the result before lah. They have some article they have shown this statement. So maybe you can search some research paper. Maybe you can get more information about this. But in fact, in practicals, is very rare. And for my experience life, I never see the BOD higher than COD. Okay.
Okay. Next question to Thomas. Wei Yen Lai from Wei Yen Lai. Investment in WWTP eligible for investment tax allowance from MIDA?
To Miss Wen, sorry to say that I also not sure. You need to check with the MIDA because mainly I'm deal with the DOE on this operation side. I never deal with MIDA before, so maybe you can get keep this inquiry from the MIDA lah. Is it can exemption or not? Because this is I never deal before. Sorry, I cannot answer this question. Yeah.
Okay. Maybe you can look through first, Wei Yen Lai, about the from MIDA punya website ke macam ni kan. Okay, next question. For Thomas from Lee, if the sample industrial effluent tested by non-accredited lab, which is from ISO 17025, is it considered violation to the regulations? Nice question.
I not say violation of the regulation, but it's not acceptable for final discharge. For final discharge, for you do the final discharge every week, you need to send a sample to this testing. We call it last time we call MDMR. Now we change to the OER, online environmental reporting. That one you need to send to the accredited lab. This one you cannot escape. But then in other parameter, not for this OER, yes, you can cross-check because performance lab you need to do in your own premises. That one your lab definitely will not have aggregated. But then in case you want to cross-check whether your result accurate or is correct or not, you can send to the non-aggregated lab to compare it. But for final discharge, you must send to the aggregated lab. This is a requirement. And also the IECS also same thing. IECS, the industrial effluent characteristic study, you need to send the sample to the this aggregated lab. So this is a requirement. Okay, Lee, thank you.
All right, thank you very much. I think we can, okay. Is there more question from the participants? Ada lagi soalan? All right, okay. Okay, so I want to share with you guys a few things about UCT, UMP Consultancy and Training. Okay. Actually, UMP Consultancy and Training, we also offered technical service and trainings, halal training, soft skills trainings, lab and water testing. We also have lab and water testing, but it does not accredited yet. Got team building, consultation, and seminars. And we also have offered other service such as consultancies. So our clients will mainly and most probably from gaming area, such as Kerti Petronas, MNI, WR Grace, Hartalega, Top Glove, and so on. We also collaborate with Innovac GmbH from Germany to produce polymer and coagulant for water treatment. Okay, please follow our Facebook for further webinars because in future we are going to share about wastewater treatment improvement and solution webinars, and we also collaborate with Central Lab UMP for any other testing and CARIF. All right, so actually we are going to take picture for all participants. So can you stay for a bit so we can take picture? Afif. Hello,
Okay, okay.
Mr. Afif.
Unshare screen boleh dapat view penuh participant. Syafika?
Yeah. Oh, saya lupa. Sorry.
Unshare screen.
Okay.
Alright. Okay, 1 minute. Okay, done. Thank you.
All right. Thank you very much, all. Thank you for your time. It's quite lengthy today. I hope you could improve your knowledge and solve your problems at the site. And you also can contact us for anything. And thank you very much. All right. Bye-bye.
Yeah, thank you, everyone. Thank you.
We will email the slides nanti to the participants. All right. Okay.
Okay.
Okay,
right.
thank you.
Thank you. Thank you, Thomas. Thank you, Dr.
Yeah, thank
June.
you.
Thank you all.
Yeah, thank you. Stay safe.
Okay.
Okay, bye.
Bye.